Alright, so let us start this video on the past paper practice. So which topic are we practicing here? We are practicing work, energy and power. This is our video number 1 on this past paper practice and therefore question number 1. The question is right in front of you. You may pause the screen here for a while, attempt the question yourself and then play the video again and score yourself and see how much you scored on this particular question. So here it is. So I believe that you have solved the question. You're coming back to the video again now. So let us see what the question is telling us to do. So the first part of the question says define power. How do you define power? It is a 1-mark question. You have to just state the formula for the power, which is work done over time, which is same as the rate of work done. Let us tally with the mark scheme to understand what Cambridge expects us to write here as the answer for defining power. Power is work done over time taken. They have just written the formula or the rate of work done. 1-mark question, easy to score, right? Now let us understand what is happening in the part B. In the figure 3.1 shows a car traveling at a speed of 22 meters per second on a horizontal road. The car has a mass of 1500 kg. The resistive force of 1200 newtons acts on the car. Calculate the force F required from the car to produce an acceleration of 0.82 meters per second square. So whenever you are given the acceleration, you know you can find the effective force or the resultant force. You are given the acceleration. This is something which I have been telling again and again. Whenever you have the acceleration, the formula F is equal to ma gives you the resultant force or the effective force, so which becomes 1500 times 0.82. And what is the resultant force on this car? Resultant force in terms of all the forces acting on the car is moving ahead, right? So that means the forward force has to be bigger. Any object always moves in the direction of the bigger force. So forward force, any object always accelerates in the direction of the bigger force. The forward force is F. It is saying the force F required from the car to produce an acceleration. You have to find this F. So in terms of these two forces that you see here on the picture, what is the resultant force? F minus 1200. So ma is this. The resultant force in terms of just the forces is F minus 1200. Now all you have to do is to solve this equation for the missing variable, which is F. So now you have to use your calculator, which is simple to do. So this whole thing is work it out on your calculators and tally with the mark scheme if you are getting the correct answer. I'll show you the mark scheme now. So here you have the mark scheme. They also are doing, if you see, exactly the same thing. You should be getting on your calculators 2403. You can round it down or you can just leave the answer at 2403. Both are correct. So 24, 20, no, I'm sorry, it is not 20, it is 2430. 2430 newtons. Alright, now let us move to the next part of the question. The power required to produce this acceleration. How do you calculate the power? Power is work done over time. Work done is force multiplied by the distance traveled, right? Over time, distance over time is velocity. So we also know, if you go through the theory lesson, you'll understand that another formula for the power in terms of the velocity is power is equal to F times the velocity. You know the velocity here, 22. So Let us input the value in the equation. What is the total force produced by the engine? We have already calculated it. 2430 times the velocity. So this, if you multiply these two numbers, you'll get the total power produced by the engine. Total power produced by the engine to move at a speed of 22. Multiply these two numbers and tally your answer with the mark scheme. It should be 53,500 on your calculators. 53,500. Unit is already given in your question, so you need not worry about it. Otherwise, you should be very clear that the unit of power is watts. W-A-T-T-S. Now the C part, the resistive force on the car is proportional to V square. We are saying that the resistive force here is proportional to square of the velocity, where V is the speed of the car. Suggest why the car has a maximum speed. So why the car has a maximum speed? 1 mark question, you have to think in terms of the terminal velocity. So as the speed will increase, the backward air resistance will increase. I'll also post my theory video on terminal velocity in the description box. Go through it. The terminal velocity, because of the presence of terminal velocity, you have a maximum speed of any moving object. So what happens at the maximum speed? The resultant force on the object becomes 0. So how can the resultant force become 0? When the resistive force becomes equal to the forward force by the engine, then the resultant force will become 0. You'll arrive at a terminal velocity. So why will the resistive force increase? The resistive force will increase because your velocity will increase. So your velocity will keep increasing, the resistive force will keep increasing until the point the resistive force becomes equal to the forward force by the engine. The resultant force becomes 0, and beyond that there will be no further increase in the velocity. Why? Because the acceleration becomes 0. This concept is explained in my video on terminal velocity. Please go through it, because I will not explain the theory here again, otherwise the explanation for this question will become very long. Here you have the same thing mentioned here as well, right? You can look at the mark scheme, understand the mark scheme, and also go through my video on terminal velocity in the description box. So in the next video, we are going to take up the next question, which will be the question number 2 on the same topic of work, energy and power. Thank you.